Welcome to the Explainer. Today, we're cracking open a really fascinating linguistic puzzle. It's one of those problems that really challenges the basic rules we thought governed language, and it shows us how a totally new way of thinking can solve something that seems, well, impossible. Okay, let's just dive right in with this sentence from Dutch. Now, at first glance, it might look pretty simple, that Jan saw Pete help Marie swim. But if you look a little closer, you see something strange. Jan saw Pete, Pete helped Marie, and Marie was the one swimming. See how the nouns and the verbs are all separated? But their meanings are all tangled up in this weird crossing pattern. So there's a name for this, of course. Linguists call it a cross-serial dependency, and for a really long time, it basically broke our best grammar models. It's the perfect example of a sentence that's super easy for a person to get, but for a computer trying to process it formally, it's a total nightmare. And this really gets to the core of the issue. You see, most of the grammars we've used for decades, the technical term is context-free grammars, they work like beads on a string. They're fantastic at connecting one word to the word right next to it. But our Dutch sentence, it needs something more. It needs connections that can jump across other words, creating those crisscrossing links. The old tools just aren't powerful enough for the job. So you can see the problem, right? Linguists knew they needed a better tool. That old left-to-right, one beat after another system just wasn't going to cut it. They had to come up with a completely new way to think about how words actually click together to make meaning. The first big breakthrough was something called categorical grammar. Now, instead of just labeling words as noun or verb, this whole approach gives them types that work kind of like formulas in logic. All of a sudden, grammar starts to feel less like a list of rules and more like a mathematical proof. So here's the basic idea of how it works. First, every word gets a logical type. Then you have rules that say how types sitting next to each other can combine and basically cancel each other out. And if you go through the whole process and you're left with just one single valid sentence type at the end, then congratulations, your sentence is grammatically correct. It's a really, really slick system. But there is a catch. As powerful as categorical grammars are, they're still fundamentally linear. They're built on the idea of adjacent words combining. And because of that, they still have a really hard time with those messy, long-distance, crisscrossing connections in our Dutch puzzle sentence. We're not quite there yet. So to really solve this, we can't just keep tweaking the old rules. We have to do something much more radical. We have to completely rethink the fundamental shape, the actual geometry of grammar itself. You know, for hundreds of years, pretty much all of linguistics has been built around one powerful idea. Language is a string. It's a one-dimensional line of words, one following the other. And that makes a lot of sense. It's intuitive, but like we've just seen, that idea has its limits. But what if language isn't a line at all? What if it's more like a network, a multi-dimensional web, where connections can reach out and link things up in all sorts of complex ways? This idea, this conceptual jump, is what changes everything. And that idea, that shift from a line to a network, opens the door to a totally new kind of grammar, one that finally embraces this more complex structure. Okay, so this brings us to the key piece of the puzzle, the hypergraph. We all kind of know what a regular graph is, right? An edge connects 2 points, point A to point B. A hypergraph is different. A single hyperedge can connect A, B, C, D, pretty much any number of points all at once. It's the perfect tool when you need to show a relationship between a whole group of things. So what happens when you take that really powerful, logical categorical grammar system and you build it on top of this super flexible hypergraph network? Well, you get something brand new. Hypergraph Basic Categorial Grammars, or HBCGs for short. It's the best of both worlds, the strict logic of one system with the multidimensional freedom of the other. All right, so now we have our new tool. Let's go back to that impossible sentence and see how this new grammar finally cracks the code. And here's where the magic happens. The hypergraph lets the grammar create one single, powerful hyperedge. You can think of it like a master link that connects all three nouns, Jan, Pete, and Marie, to their verbs, saw, help, and swim, all at the same time. This one nonlinear connection nails the meaning. Jan saw, Pete helped, Marie swam. The tangled mess is gone. It just works. And the really cool thing here is that this isn't just about getting a pass or fail on the grammar. It's about creating a model that actually shows the true interconnected meaning, the semantics of the sentence. The structure of the grammar finally mirrors the structure of the thought. It's really elegant. Now, you might be thinking, okay, cool, you found a clever fix for one weird Dutch sentence. But it's really important to see that this shift in thinking is actually way bigger than that. What this really does is move our whole understanding of grammar from that one-dimensional line to a multidimensional web. And that gives us a much, much richer way to think about the structure of meaning itself. It builds these amazing bridges between linguistics, computer science, and formal logic. And it just goes to show how incredibly sophisticated our models of language can be. So, I want to leave you with this final thought. If the structure of our language, the very tool we use to form our ideas, isn't just a simple line, but this complex, interconnected web, what does that tell us about the shape of human thought itself?